With one of the craziest discoveries you can imagine, we're here to take you on an exciting cosmic journey. Did you know that there's alcohol in massive nebulae floating in space? Yes, you heard it right. Alcohol really exists out there. If we could one day travel inside molecular clouds like Sagittarius B2 or the Orion Nebula, though this seems unlikely for now, we might find ourselves wondering, would we get drunk? Of course, we're joking. The alcohol we're talking about is a bit different from what we pour into our glasses. Instead, we're referring to organic molecules like ethyl alcohol, ethanol, methanol, and even glycol. But what's really important is what this discovery of organic molecules deep in space tells us. This brings us to the very foundation of life. The existence of such molecules indicates that the building blocks of life are not exclusive to Earth. Rather, they highlight a rich chemical diversity that could be present throughout the universe. Let's explore how this cosmic alcohol party was discovered and why it matters. How was alcohol discovered in nebulae? In the mid-1970s, astronomers made a surprising discovery in Sagittarius B2, a massive molecular cloud near the center of the Milky Way, ethyl alcohol. Naturally, they wanted to make sure their telescopes hadn't picked up something random like dish soap residue. After all, who would think there's alcohol in space? But after analyzing the spectrum of light using spectroscopy, they confirmed the presence of ethanol. Another fascinating cosmic phenomenon can be found in the Orion Nebula. This nebula is one of the densest regions of gas and dust in space. Here, scientists detected large amounts of organic molecules such as methanol and formaldehyde. Among these, more complex substances like glycol were also observed. In short, it wouldn't be wrong to describe space as a massive chemistry lab. How do alcohol clouds form? Though space might seem like a vast emptiness, it's anything but. In regions known as molecular clouds, elements such as hydrogen, carbon, and oxygen, along with tiny dust particles, float around. Thanks to extremely low temperatures and cosmic radiation, these atoms and molecules interact, forming organic compounds like ethyl alcohol, methanol, and many more. The surface of dust grains acts as miniature factories where these molecules are synthesized. Why is this extraterrestrial alcohol important? The discovery of organic molecules in different parts of space suggests that the chemical foundations of life could be widespread across the universe. The molecules involved in the formation of life on Earth aren't just drifting around in isolation. They might be found all over the cosmos. This raises the intriguing question, is life unique to Earth? Amino acid precursors. These molecules, the building blocks of proteins, have been detected in interstellar clouds. Water vapor, an essential ingredient for life. Water is abundant in gas clouds. Polycyclic aromatic hydrocarbons, PAHs, these large organic molecules, a key component of interstellar dust, may play a crucial role in the emergence of life. What's next? Of course, the ethanol detected in space is found under vastly different conditions than the alcohol we know on Earth. These molecules exist in extremely low densities and in environments filled with intense cold and radiation. So, putting aside the joke, a cosmic bar tour remains purely in the realm of imagination. However, these discoveries provide invaluable insights into how molecules form in extraterrestrial environments and how widespread the foundations of life could be. This leaves us with a tantalizing question. What other signs of life's building blocks might we uncover in space? A glass of the universe, with a side of curiosity. The discovery of alcohol in space is a striking example that excites the worlds of chemistry and astrobiology. It shows us how rich the organic diversity beyond our planet can be. Moreover, since these molecules might eventually become part of planetary systems, they reshape our understanding of how life might emerge elsewhere in the universe. So, if we could one day actually travel to Sagittarius B2, we might finally understand what these molecules mean for the universal foundations of life. Thank you for watching, and don't forget, there are still countless crazy surprises waiting to be discovered in the universe.